In this video, we will find how many real roots does this equation have as function of real b. This equation belongs to so-called transcendental equations because it contains non-algebraic function ln x. Another examples of such equations contains either exponential function or trigonometric function. In general, transcendental equations have only numerical solutions, but sometimes, if you are lucky, you can find the root by trial and error method, or you can analyze this equation by graphical method and find important features of this equation. In this video, we will use graphical method, and first we sketch the graph of the left-hand side of our equation. Then we will find maximum of this equation, xm and ym coordinates. And finally, we will analyze points of intersection of the graph with the line y equal b. The number of these points gives us the number of real roots of this equation, and we can estimate the values of these roots. Later, we will use obtained result to analyze other transcendental equations. First, we will sketch the graph of the left-hand side of our equation. Left-hand side is a function of this form. We select coordinate system, and first we will find some characteristic points and some characteristic features of this function. Let's consider x equal 1. In this case, our function is equal 0, and this point will be here. Next, we consider our function at x approaching 0. In this case, we need to find this limit. Ln x approaches negative infinity, x approaches 0, so this function approaches negative infinity. It means that the graph here at x less than 1 looks like this. This is just a sketch. Next, we will consider behavior of this function at x approaching infinity. We consider the limit of this function at x approaching infinity. We use L'Hopital's rule to find this limit. Derivative in numerator is 1 over x. In denominator it is 1. So we have here 1 over x, or the limit equal to 0. Schematically, we can draw here the part at large x. It will look like this. Between these points, we can assume that the function has a maximum, and as a next step, we should find coordinate of this maximum, xm and ym. To find coordinates of maximum, we need to find first derivative of our function and equate to 0. We calculate this derivative using the standard equations for derivatives of the fraction, and after some calculations we will get it is 1 minus ln x over x squared, and this should be equal 0. Numerator is equal 0 at ln x equal 1. From here we find x coordinate of maximum, it is e. To find y coordinate of maximum, we plug in xm into our function, and we get the following results. This coordinate is equal 1 over e, or approximately 0.3679. Now we return to solution of our equation. Here is a plot of left-hand side, plotted with the help of computer. It's a nice curve. We know position of maximum. And now we take into account that solution of this equation is point of intersection of this curve with the curve y equal b. So this line is parallel to axis, and now we can study the various situations. First, we consider the range b less than 0. B less than 0. So we investigate this range. We see that here, at any point, there is only one point of intersection. So it means that there is a single root for b smaller or equal 0. For range between 0 and ym for b, we have 2 points of intersection, so in the entire range we have 2 roots here. At point ym, there is only one point of intersection, so we have again single root for b equal 1 over e or ym. And for b greater than ym, this range, there is no points of intersection. It means equation has no roots. Now we can make a conclusion. Our equation at b less or equal 0 and at b equal 1 over e has a single root. For b in this range, equation has 2 roots. And for b greater than 1 over e, equation has no roots. We can illustrate this conclusion using the following diagram. Here we plot value of b. The points here which are important is b equals 0 and b equal 1 over e. And we see that on the left to the 0 we have single root. Between 0 and 1 over e, equation has 2 roots. At 1 over e exactly there is a single root, and at b greater than 1 over e we have no roots. So the problem is solved completely. If you like this video, you may hit like icon, leave a comment and subscribe for the channel.